Hey everyone, and welcome to BroderCAD. Let me ask you a question. Do you know how to use SolidWorks, but when you look at your portfolio, you feel like it's not strong enough? If so, you are in the perfect place. This channel is dedicated to one single goal, helping you build a better portfolio by solving real-world design problems. And the project we are starting today is a perfect example. We are going to be modeling a complete gym shaker bottle. This idea came from a problem I personally faced. I was tired of my protein shakes getting clumpy and warm. So, we'll design a bottle that stores the protein powder in a separate compartment, with a push-button mechanism to release it the moment you need it. This way, you can have a fresh protein shake anytime. If you're ready to create models that solve real problems, make sure to subscribe and hit the bell. Let's go! First, let's set the units for our project. We'll be working in millimeters, so select mmgs. With the unit set, we can begin. Select the top plane and open a new sketch. Grab the circle tool and draw a circle, setting its diameter to 71 millimeters. Next, exit the sketch. We need to create a new reference plane parallel to the top plane. Go to Reference Geometry and select Plane. Choose the top plane as your reference and set the offset distance to 164 millimeters. Click OK to create the new plane. Now, select this new plane and start another sketch on it. Using the circle tool again, draw a circle with a diameter of 85 millimeters. Once that's done, you can hide the reference plane to keep the workspace clean. With our two circular profiles ready, navigate to the Features tab and select the Lofted Bossa Base tool. Select both circles as the profiles for the loft. This will create the basic solid body of our bottle. Next, we'll create the punt, which is the concave dimple at the base of the bottle that adds strength and stability. For this step, select the right plane and open a new sketch. Grab the 3-point arc tool. Create an arc inside the base of the bottle. Now, let's dimension it. We'll define the arc by setting the endpoints 12 millimeters apart, with a height of 7 millimeters, and the midpoint at 5 millimeters height from the base. To fully define it, select the origin and the endpoint of the arc's chord and add a vertical relation. To make this a closed profile for our cut, use the Line tool to draw a line connecting the two endpoints of the arc. With the sketch complete, go to the Features tab and select Revolve Cut. For the axis of revolution, select the central axis line of your model. This will carve out the punt. Now, let's hollow out the bottle. Select the Shell feature from the Features tab. Choose the top face of the bottle and set the wall thickness to 2 millimeters. You can click Show Preview to see how it will look. If you're happy with it, click OK. With the main body done, let's create the neck. Select the right plane again and start a new sketch. Begin by drawing the basic profile shape of the neck with the Line tool. Now, use Smart Dimension to define its geometry. We'll set the length to 16 millimeters and the width to 2 millimeters, and again width to 3.5 millimeters. We made an error, entering the dimension as 21 millimeters instead of 16 millimeters, and set this line length as 16 millimeters. To position the neck correctly, We set the dimension between the origin and the bottom point of the neck sketch to 40.5 millimeters. Once the sketch is fully defined, go to the Features tab and select Revolved Boss Base. For the axis of revolution, select the central axis line. As showing in the video, go to the eye icon to make the central axis line visible. Ensure the Merge Result option is checked to combine the neck with the bottle body, and then click OK. First, we need to create the helical path for the threads. So, go to the reference plane and select the top face of the neck and give the distance of 5 millimeters from the selected surface to the reference plane and click OK. Start a new sketch. Select the outer edge of this face and use the Convert Entities tool. This creates a circle in your sketch that perfectly matches the edge. Now, go to Insert, Curve, Helix or Spiral. In the Properties, define the helix using a variable pitch. Set up the parameters as follows: set the pitch to 9, and revolution is already set to 0. In the next row, set the pitch as 9, and revolution as 0.08, and diameter as 85. Moving towards next row, pitch as 9, and revolution as 1.02, and in next row again pitch as 9, and revolution as 1.1. You might notice our helix is going in the opposite direction. To fix that, just click on Reverse Direction. Next, let's set it to clockwise and change the starting angle to 18 degrees. Go ahead and click OK to generate the curve. Next, we'll draw the thread's 2D profile. Go to Reference Geometry or Plane. For the first reference, select the axis. For the second reference, select one point of helical curve itself. This creates a plane positioned perfectly for our sketch. Select this new plane and start a sketch. Draw the thread profile using the Line tool and a central construction line for reference. Use Smart Dimension to set this angle to 3 degrees, and this one to 30 degrees. The width should be around 1.5 millimeters, and this width to 0.7 millimeters. We've completed the sketch. To lock the profile onto the path, select the point on your sketch that needs to follow the helix. Hold Ctrl, select the helical curve, and add a pierce relation. With the profile perfectly aligned, go to the Features tab and select the Swept Boss or Base tool. Your thread profile sketch should already be selected for the profile. For the path, simply select the helical curve we created. Click OK to generate it. Afterward, you can hide the helical curve and the reference plane. Finally, to give the thread a smoother start and finish, select the Fillet tool. Choose the sharp edges at the beginning and end of the thread and apply a 10 mm radius to create a rounded, clean transition. After that, go to the Features tab and select Circular Pattern. Choose the sweep and fillet we just created, and then select the axis. We will get the perfect thread profile. Alright, we have now successfully completed the main body of the bottle. With that major component finished, it's time to move on to the next essential part of our assembly. In this section, we are going to focus entirely on modeling the cap. This will involve creating the overall shape, adding the internal threads, and ensuring it will fit perfectly onto the bottle we just made. So, let's begin. Let's start by selecting the front plane and opening a new sketch. We'll use the line tool to draw the base shape of our cap. You can automatically convert the line tool into an arc tool by moving your cursor back to the endpoint of the line. Next, use the 3-point arc tool to draw the top curved surface. The basic sketch is finished. Let's add dimensions to fully define the sketch. Use the Smart Dimension tool to set the base radius to 46 mm, the height to 40 mm, and the large arc radius to 52 mm. For the smaller arc, set the width to 7 mm, the radius to 6 mm, and this line length to 16 mm. The sketch is now fully defined. Now, go to the Features tab, choose Revolved Boss Base, and select the center axis of your sketch. Click OK to create the solid body of the cap. We now have the solid structure of our cap. Let's create a new reference plane. Go to the Reference Geometry menu and select Plane. For the first reference, select the base surface of the cap. If the new plane is facing the wrong way, select the Flip Offset option to reverse its direction. Set the offset distance to 47 mm and click OK. Select the new plane you just created and start a new sketch. Choose the Circle tool and draw a circle on the plane. Use the Smart Dimension tool to set the circle's diameter to 28 mm. Set the horizontal distance from the circle's center point to the origin to 22 mm. To fully define the sketch, add a horizontal relation between the circle center and the origin. With the sketch ready, navigate back to the Features tab and select Extruded Boss Base. Ensure your circle sketch is selected as the profile. For the end condition, choose Up to Next, which automatically extends the extrusion until it merges with the next solid body. Click OK. The new feature will be perfectly connected to the main body of the cap. Right-click on the reference plane and select Hide. Select the Shell feature from the Features tab to begin hollowing out the body. Select the top and bottom surfaces of the cap and set the wall thickness to 2 mm. Then click OK. Next, we'll create another reference plane for the threads. Go to Reference Geometry, select Plane, and choose the base of the cap as your reference surface. Since the plane is created in the opposite direction, check the Flip Offset box to reverse it. Set the distance to 1.9 mm and click OK. Select the plane you just created and start a new sketch. Select the inner edge at the base of the cap and click the Convert Entities tool. This will project an exact copy of that edge onto your sketch plane. With the sketch selected, go to the Features tab and navigate to curves Helix and Spiral. In the Property Manager, define the helix using variable pitch and enter the following values. Set the pitch to 9, and revolution is already set to 0. In the next row, set the pitch as 9, and revolution as 0.1, and diameter as 88. Moving towards next row, pitch as 9, and revolution as 1, and in next row again pitch as 9, and revolution as 1.25. Ensure the helix is extending in the correct direction. If needed, use the reverse direction option. Confirm these settings: start angle, 18 degrees, and rotation, clockwise. Click OK to generate the curve. Your helical path is now ready. First, hide the previous reference plane to keep your view clean. Next, go to the eye icon drop-down menu and select Axes to make the central axis visible. Now, let's make a new reference plane for drawing the thread's profile. Go to Reference Geometry and select Plane. For the first reference, select the central axis. For the second reference, select the endpoint of the helix curve. A new plane will be created. Click OK. Select the new plane you just created and start a new sketch. You are now ready to draw the thread profile. Select the Line tool to draw the basic shape of the thread. Next, use the Centerline tool to add a construction line, which will serve as a reference for your dimensions. Use the Smart Dimension tool to define the shape of the profile with the following values. Set the first angle to 3 degrees, set the second angle to 30 degrees, define the width as 0.7 mm, and set the length to 1.5 millimeters. Once these are applied, the sketch is complete. Now, select the key point on your thread profile sketch, hold the Control key, and select the helical curve. In the context menu that appears, select Pierce. The profile will be perfectly constrained to the starting point of the helix. Select the Swept Bossa Base command from the Features tab. Your thread profile sketch should already be selected in the profile box. For the path, select the helical curve. Click OK to generate the feature. The thread is now created. Start by hiding the plane used for the thread profile to get a clearer view. From the Features tab, select the Circular Pattern tool. For the pattern axis, select the central axis of the model. Under Features to Pattern, select the sweep feature you just created. Click OK to complete the feature. Before we continue, we need to add fillets for smoother transitions on the thread. To do this correctly, we'll insert the feature before the circular pattern. In the design tree on the side panel, click and drag the rollback bar upward so it's positioned just above the circular pattern feature. You'll see the circular pattern temporarily disappear from the model. Now, select the Fillet tool from the Features tab. Apply a 10 mm fillet to the start and end edges of the single thread and click OK. Drag the rollback bar back down to the bottom of the feature tree. Right-click on the circular pattern feature and choose Edit Feature. Click inside the Features and Faces selection box. Now, add the new fillet to the list of features to be patterned by selecting it from the design tree. Click OK. Go to Reference Geometry and select Plane. Choose the base surface of the cap as the reference. Set the offset distance to 0 mm to create a plane that is perfectly aligned with the base. Click OK. Then select the new plane and start a new sketch. Use the Circle tool to draw a circle and set its diameter to 44 mm. Dimension the horizontal distance between the circle center and the origin to 14 mm. Then, select the Offset Entities tool, choose the Circle, set the distance to 2 mm, and check the reverse direction box to place the offset on the inside. Navigate to the Features tab and select Extruded Bossa Base. Set the end condition to Up to Next and click OK. Finally, hide the plane to keep the viewport clean. Now, let's repeat the threading process. We will create a reference plane 5 mm away from the bottom surface and flip it. Select the outer edge of the bottom feature and use the Convert Entities tool to project it into your sketch. Navigate to Features a Curves, a Helix, and Spiral. In the Property Manager that appears, set the definition type to Variable Pitch. Set the pitch to 9 mm and the revolution to 0. In the next row, set the pitch to 9 mm, the revolution to 0.08, and the diameter to 44 mm. In the next row, set the pitch to 9 mm and the revolution to 1.02. In the next row, set the pitch to 9 mm and the revolution to 1.1. Click OK to generate the curve. The helical path is ready. Hide the reference plane and ensure the central axis is visible. If not, go to the icon and enable the axis. Go to Reference Geometry Plane. For the first reference, select the central axis. For the second reference, select the endpoint of the new helical curve. Click OK to create the plane. Start a new sketch on the plane you just created. Use the Line tool to draw the basic profile shape and a centerline to use as a reference for your dimensions. Use Smart Dimension to define the sketch. Set the primary width to 1.5 mm. Set the line length to 0.7 mm. Set the angle between the construction line and the profile line to 3 degrees. And set the second angle to 30 degrees. To align the sketch, select the point on your profile that will follow the path, hold Ctrl, and select the helix. Add a Pierce relation. Go to the Features tab and select Swept Bossa Base. Your profile sketch will already be selected. For the path, select the helical curve. Click OK to create the single thread. Select the fillet tool and apply a 10 mm radius fillet to the sharp edges at the beginning and end of the thread for a smooth transition. Next, select the Circular Pattern tool. For the pattern axis, choose the central axis. Under Features to Pattern, be sure to select both the sweep and the fillet feature. Click OK. The threads are now complete. Now, let's take a cross-section view to check the inside. Everything looks perfect. Our threads are complete. Select the front plane and start a new sketch. Use the Line tool to draw a simple rectangle. Use the Smart Dimension tool to position and size the rectangle. Set the distance from the model's base to the bottom of the rectangle to 17 mm. Set the distance from the center axis to the inner edge of the rectangle to 21 mm. Set the length of the rectangle to 4 mm. And set the width of the rectangle to 3 mm. Navigate to the Features tab and select the Revolved Bossa Base tool. When prompted for the axis of revolution, select the central axis of the model. Click OK. First, select the reference plane that you created at a 47 mm distance from the base. Start a new sketch on this plane. Draw a circle, ensuring its center is horizontal to the origin. Use Smart Dimension to set the distance from the origin to the circle center to 14.5 mm. The circle's diameter to 15 mm. Let's create the extruded cut. Navigate to the Features tab and select Extruded Cut. Set the end condition to Up to Surface and select the bottom face of the model as shown. Click OK to make the final cut. That completes our cap model. Go to the Fillet feature, select the edges to fillet, set the radius to 1 mm, and click OK. Select the front plane, go to Reference Geometry, select Plane, and set the distance to 21 mm, then click OK. Click on the plane we just created, select Sketch, go to the Convert Entities drop-down, and select Intersection Curve. Select the surface and click OK. Now, select the Line tool and start drawing the basic shape as shown. Go to the Smart Dimension tool, click on the arcs point and the origin, and enter the distance as 21 mm. Set the width of the arc to 8.5 mm. The line height to 18 mm. And the distance from the base to the curve's point to 47 mm. Now, select the Centerline tool and draw a line in the middle as a reference for the mirror. Go to the Mirror feature, select the lines to mirror in the Entities to Mirror box, and select the centerline for Mirror About. Click OK. Now, select the Trim tool, trim the unwanted lines from the sketch, and click OK. Go to the Features tab, select Extruded, Bossa Base, change the direction, and set the end condition to blind with a depth of 4 mm. Click OK. Just select the surface, create a sketch, and draw a circle. Select Smart Dimension and enter the circle diameter as 7 mm. Select the circle's center point and this point, and set the distance to 9 mm. Now, go to the Features tab, select Extruded Cut with a distance of 2 mm, and click OK. Click on the Mirror feature. Select the front plane as the plane to mirror about. Select the features, and click OK. Our model is now complete. Alright, we have now successfully completed the cap of the bottle. With that finished, it's time to move on to the next essential part of our assembly. In this section, we are going to focus entirely on modeling the top cap. This will involve creating the overall shape and ensuring it will fit perfectly onto the cap we just made. So, let's begin. Let's begin to make the flip-top lid. To begin, select the front plane and start a new sketch. Using the line tool, draw the basic profile shape for the flip-top lid. Next, select the Smart Dimension tool to define the sketch. Apply the following dimensions as shown. Set the length to 43 mm. Set this line length to 29 mm. Apply the final angular dimension of 150.92 degrees to fully define the sketch. Your base sketch is now complete, and click OK. Select the Offset Entities tool, and choose the lines from the sketch we just drew. In the Properties panel, check the bidirectional option, and set the offset distance to 4 mm. Click OK. Now, select the original sketch lines, and convert them to construction geometry. Finally, use the Line tool to close the open ends of the offset, creating a single closed profile. Navigate to the Features tab, and select Extruded Bossa Base. For the end condition, choose Mid-Plane. Set the extrusion distance to 33 mm, and click OK. The basic solid body of the flip-top lid is now created. To create a smoother transition, select the Fillet tool from the Features tab. Choose the sharp inner and outer edges of the main bend. Set the fillet radius to 10 mm, and click OK. Select the flat side surface of the model, and start a new sketch. Use the Circle tool to draw a circle. Dimension the distance from the origin to the circle center as 21 mm. And set its diameter to 7 mm. To fully define the circle's position, we'll reference our original base sketch. In the Feature Manager design tree, find the first sketch you created for the lid. Right-click on it and select the eye icon to make it visible. With your current sketch still open, select the base sketch. Click the Convert Entities tool to project this line into your current sketch. Finally, select the newly projected line and convert it to construction geometry. This will serve as a perfect reference to fully define your circle's position. Select the center. Hold the Control key and select the construction line you just created. Add a coincident relation. Your sketch is now fully defined. With your side sketch selected, go to the Features tab and choose Extruded Bossa Base. Set the end condition to blind and the depth to 2 mm. Click OK. Next, select the Mirror tool. For the mirror face plane, choose the front plane. Under Features to Mirror, select the Boss Extrude feature you just created and click OK. Select the bottom surface of the lid and start a new sketch. Draw a circle and use Smart Dimension to set its distance from the outer edge of the model to the circle center as 21 mm. Diameter to 29 mm. Add a horizontal relation between the circle center and the origin to fully define it. Go to the Features tab and select Extruded Cut. Set the end condition to blind with a depth of 2 mm and click OK. Start another new sketch on the bottom surface. Select the edge of the circular cut you just made and use the Convert Entities tool. Next, select Offset Entities. Choose the converted circle, set the offset distance to 1 mm, and make sure bi-directional is turned off. Navigate to the Features tab and select Extruded Bossa Base. Set the end condition to blind with a depth of 6 mm and click OK. Select the top plane and start a new sketch. Draw a vertical centerline to serve as a reference. Using the line tool, draw 1/2 of the cutout shape next to the centerline. Use the Smart Dimension tool to define the sketch with the following values: bottom point to side edge 4 mm, middle point to side edge 6 mm, top point to side edge 12 mm, distance from this point to the base 17 mm, Next, select the Mirror Entities tool. Choose the lines you just drew and mirror them across the centerline. Finally, use the Line tool to connect the endpoints and create a fully closed sketch. Navigate to the Features tab and select Extruded Cut. In Direction 1, set the end condition to Up to Surface and select the bottom surface of the model. Activate Direction 2, set its end condition to blind, and enter a distance of 10 mm. Click OK to create the cut. To get a smooth, finished product, we'll add fillets in 3 steps. Select the Fillet tool. Choose the sharp inside edges of the cut you just made, and set the radius to 2 mm. Click OK. Activate the Fillet tool again. Select the main front edge and set the radius to 10 mm. Click OK. Finally, use the Fillet tool one last time. Set the radius to 1 mm and select all of the remaining sharp edges on the model. Click OK. Your smooth flip-top lid is now complete. We have now completed the top cap of the bottle. Our next task is to model the container that holds the powder. This component is another major part of our design, and it will sit inside the main bottle. Let's get started on it now. Select the top plane, start a sketch, and draw a circle centered on the origin. Use Smart Dimension to set the diameter to 51 mm. From the Features tab, select Extruded Bossa Base. Set the end condition to blind, with a depth of 20 mm and click OK. Next, select the Shell tool. Choose the top and bottom surfaces to remove and set the thickness to 2 mm. Use the Show Preview option to check the result, then click OK. Go to Reference Geometry, Plane. Select the top surface as the reference, set the distance to 2.3 mm, and check the Flip Offset box. Start a sketch on this new plane. Select the inner circular edge and use the Convert Entities tool. Go to Features tab, Curves, Helix, and Spiral. In the Properties, choose Variable Pitch and enter the following values. Set the pitch to 9, and revolution is already set to 0. In the next row, set the pitch as 9, and revolution as 0.1, and diameter as 47. Moving towards next row, pitch as 9, and revolution as 1, and in next row again pitch as 9, and revolution as 1.25. Ensure the helix is extending in the correct direction. If needed, use the reverse direction option. And, confirm these settings. Ensure start angle is 18 degrees. Rotation in clockwise. Click OK to generate the curve. Your helical path is now ready. Hide the plane. To make the axis visible, go to the View menu, icon, and enable axis. Create a new reference plane using the central axis as the first reference and the endpoint of the helix as the second. Start a sketch on this new plane. Draw the thread profile shape with a line tool and a center line for reference. Use Smart Dimension to define the profile. Set the angle between the center line and the bottom line to 3 degrees. Set the angle between the two angled lines to 30 degrees. Set the width to 0.7 mm and the length to 1.5 mm. Select a point on the thread profile and the helix curve, then add a pierce relation to align them. Select the Sweep tool. The profile will be pre-selected. For the path, choose the helix. Click OK. Let's hide the plane from the workspace. Now, go to the Circular Pattern tool, choose the center axis, and select the sweep in the Features and Faces box. Click OK. We had forget to add fillet before the circular pattern. To add fillets, drag the rollback bar in the design tree to just above the circular pattern. Select the fillet tool and apply a 10 mm fillet to the start and end of the thread. Drag the rollback bar back to the bottom. Edit the circular pattern feature, add the new fillet to the Features to Pattern box, and click OK. Select the bottom surface of the neck and start a sketch. Draw a circle centered on the origin with a diameter of 51 mm. Select Extruded Boss or Base. Set the end condition to blind, the depth to 50 mm, and add a draft angle of 2 degrees. Click OK. To hollow the body, select the Shell tool. Choose the top opening and the bottom surface to remove. Set the thickness to 2 mm and click OK. Select the front plane and start a sketch for the internal rib. Draw the profile shape as shown in the video. Select the Smart Dimension tool and enter the following distances. The distance from the center line to this line is 3 mm. This line is 1.5 mm. The height is 26 mm. The distance from this line to the center is 6 mm. The top width is 1 mm. And the distance from the bottom to this line is 21 mm. Our sketch is now fully defined. Select the Revolved Boss or Base tool and choose the central axis to create the rib. Let's enable the cross-section view of the model. Start a final sketch on the front plane for the external lug and draw the shape as shown. Use the Smart Dimension tool to define the sketch. Set the distance between this line and the center axis to 6.5 mm, the length to 17.2 mm, and the width to 4 mm. The distance from the bottom edge to this line is 32 mm. Our sketch is now fully defined. Select Extruded Boss or Base. Choose mid-plane for the end condition and set the depth to 3 mm. Finally, select the Circular Pattern tool. Choose the central axis, select the lug feature to pattern, set instance count to 2, and click OK. The model is now complete. With the last part finished, it's time to model the blocker. This is a critical component that stops the powder from being released prematurely. It gives the user full control over when the mixing happens. Let's get started on this model. Let's begin. Select the front plane, start a sketch, and choose the line tool to draw the basic shape of the blocker, following the video exactly. After completing the sketch, choose the Smart Dimension tool. The dimension from that point to the bottom line is 20 mm, and the distance from this point to the origin is 20 mm. The bottom line length is 22 mm. This line length is 1 mm. This line length is 3.5 mm. And this line is 2 mm. Our sketch is now complete. Go to the Features tab, select Revolve Boss Base, and select the axis to revolve as shown. Click OK. Now, select the top surface, start a sketch, and use the Circle tool to draw a circle with a dimension of 6 mm. Click OK and move to the Features tab. Select Extruded Cut and choose Blind with a distance of 2 mm. Click OK. Now, select the Fillet tool, choose the edge, and give it a smooth transition with a fillet radius of 10 mm. Click OK. We have completed the model. We have finished modeling the blocker. Next, we will model the rod. This is the component that pushes the blocker whenever the user activates the button. Let's start on this new part now. Let's create this model. Select the top plane, choose the Circle tool, and draw a circle centered on the origin. Select Smart Dimension and enter the diameter as 5.5 mm. Go to the Features tab, select Extruded Boss Base, and choose Blind with an extrude length of 67.88 mm. Then click OK. Now, create a reference plane. For the reference, select the base of the created rod and flip the direction, as it's going in the opposite direction. Enter the reference distance as 38.90 mm and click OK. Select the new plane, start a sketch, and select the outer edge as shown. Click on Convert Entities. We have now created the sketch on the current plane. Next, select Offset Entities. Choose the sketch that we created using Convert Entities, and enter an offset distance of 1.5 mm. Click OK. Now, go to the Features tab, select Extruded Boss Base, and choose Blind with an extrude distance of 2 mm. Click OK. We have completed our model. We have now completed the rod. The next component we will model is the spring. This part is responsible for pushing the rod back into place, which closes the blocker when the user releases the switch. Let's get started on this model. Let's make the spring. First, select the front plane, start a sketch, and draw a line. It is important that while drawing the line, you do not give it a relation to the origin. Select Smart Dimension and set the length to 26 mm. After that, select Centerline from the Line tool drop-down and draw a line perpendicular to the one you just drew. Select Smart Dimension and enter the length as 4 mm. Now, let's exit the sketch. Again, select the front plane, start a new sketch, and draw a circle. Select Smart Dimension and enter the diameter of the circle as 0.6 mm. Let's add the relations. Select the circle and the construction line and add a tangent relation. Next, give a horizontal relation by selecting the endpoint of the construction line and the center of the circle. After that, let's exit the sketch. Go to the Features tab and select Sweep. For the profile, select the circle, and now we need to add the path by selecting the line sketch. After that, go to the Options section, set the profile orientation to keep normal constant, and for profile twist, select Specify Twist Value. For twist control, select Revolutions and enter 11. Click on Merge Tangent Faces. Now we can see the spring, so click OK. We have completed our spring model. After completing the spring model, our next component is the switch. This is the part the user will press to open the container. Let's model it now. Let's create switch, so first, select the front plane and start a new sketch. Using the circle tool, draw a circle canted on the origin. Use Smart Dimension to set the diameter to 15 mm. Go to the Features tab and select Extruded Bossa Base. Set the end condition to blind with a depth of 20 mm and click OK. To break the sharp edge, select the chamfer tool. Choose the front circular edge and set the chamfer distance to 1 mm. Click OK. Next, select the bottom surface of the model and start a new sketch. Draw a circle and set its diameter to 5.5 mm. From the Features tab, choose Extruded Bossa Base. Set the end condition to blind with a depth of 4 mm and click OK. The switch model is now complete. Alright, the switch is done. That means all of our parts are now modeled. It's time to put them all together. We are now moving on to the assembly to see how everything fits and works. Let's go. Let's begin our assembly. First, we'll go to Insert Components and select our container and stem. I've named them simply. The container is what holds the protein powder, and the stem is the rod that will open the container. Click Open, and place the container in the workspace first, followed by the stem. To start the assembly, let's create our first mate. Click on the cylindrical surface of the stem and select Mate. For the mating surface on the container, select the inner ribbed surface as shown. We'll apply a concentric mate to align them perfectly. After setting the relation, click the green check mark to confirm. For a better look inside, let's switch to a section view. It looks like the stem is facing the wrong way. No problem. In the design tree on the left, find the concentric mate we just created, right-click it, and select Edit Feature. In the Mate options, simply flip the mate alignment. There, that looks correct. Now, let's limit the stem's movement so it doesn't fall out or push too far. Go into the Mate menu, select the Advanced Mates tab, and choose the Distance Mate. Select the two surfaces that will define the travel range, as shown in the video. Set the maximum distance the stem can travel to 25.50 mm. Set the minimum distance to 10 mm. Click OK. Now, if you try to drag the stem, you'll see it's perfectly constrained within that range. Excellent. Let's bring in the next part. Go to Insert Components and select the spring. Drag it into the workspace and click the Rebuild button, the traffic light icon, to refresh the view. To mate this spring correctly, we need to use its internal sketch. In the design tree, expand the spring part, find its sketch, and make it visible by clicking the icon. Click on the center line within the sketch and select Mate. Mate it to the cylindrical body of the stem using a concentric relation and click OK. Now, we need to make the spring stretch and compress with the stem. We'll do this by editing the spring sketch directly within the assembly. Save your assembly first. Select the bottom point of the sketch line and the flat surface inside the container, as shown. Apply a coincident relation. You may need to remove any existing length dimensions on the sketch line so the assembly can control it. Using the Smart Dimension tool, create a new dimension between the top point of the sketch line and the edge of the stem as shown. Set this distance to 1 mm. Click OK and exit the sketch. The spring is now perfectly aligned and ready to function. Time for the magic. Try moving the stem down and hit the Rebuild button. You'll see the spring compress. Move the stem up and rebuild again. It expands back. Our spring mechanism is working perfectly. Alright, let's add the blocker. This is the crucial part that holds the powder in the container until you're ready to release it. Go to Insert Components, select the blocker, and place it in the workspace. If you can't see it, it's because our section view is still active. Let's turn that off for a moment. Now that you can see the blocker, turn the section view back on and adjust the plane so we can see what we are doing inside. Select the circular surface of the blocker as shown and click Mate. Select the circular surface of the stem and apply a concentric mate. To lock the blocker to the stem, select the bottom face of the stem and the top face of the blocker, as shown, and make them coincident. Click OK. Now, when the stem is pushed down, the blocker opens the container to release the powder. This design is fantastic because it keeps the powder separate until you're ready to mix, ensuring a fresh drink every time. It also prevents those messy powder spills we all hate. Let's get back to our project. Next, go to Insert Components and browse for the cap model. Click on the inner cylindrical surface of the container and select Mate. Select the corresponding surface on the cap and apply a concentric mate. Go to Advanced Mates and select a distance mate. Constrain the movement between the top of the container and the cap with a maximum distance of 50 mm and a minimum of 0 mm. Go to Mechanical Mates and select the screw mate. Set the option to Distance a revolution. Set the distance to 9 mm, which matches the pitch of our threads. Now, carefully select the helical edge of the container's thread and the matching thread on the cap. Click OK. Give it a spin. You'll see the cap twists on and off perfectly, just like the real thing. We are almost there. Go to Insert Components and browse for the top cap. Select the surface as shown on the top cap and mate it to the inner surface of the main cap with a concentric relation. To get this top cap perfectly canted between the two hinges, we'll use a handy advanced mate. Go to Advanced Mates and select Width. For the first set of selections, the width selections, pick the two outer faces of the hinges. For the second set, the tab selections, pick the two side faces of the top cap. SolidWorks will automatically center it for you. Perfect. Finally, let's bring in the bottle. Insert the component and place it in the workspace. To make things easier, let's right-click the bottle and fix it in place. Now, let's attach our assembled cap to the bottle. Select the inner surface of the cap and mate it to the neck of the bottle with a concentric relation. Just like before, go to Advanced Mates, Distance, and set the travel between the cap and bottle with a maximum of 50 mm and a minimum of 0 mm. One last time, let's add a mechanical mate. Select Screw, set the distance a revolution to 9 mm, and select the threads on the bottle and the cap. Click OK. Our screw mate is working perfectly. For the final piece of our mechanism, let's add the button. Go to Insert Components, browse for the switch button model, and place it in the workspace. Select the main cylindrical surface of the button and click Mate. Now, select the hole in the cap that we designed for it. Apply a concentric mate. You might need to flip the mate alignment to ensure it's pointing the right way. Click OK. Next, drag the button up slightly so you can see underneath it. Select the bottom face of the button and the top face of the stem. Let's make them coincident. Click OK to lock them together. To get a clear view of how this all works, right-click the bottle in the design tree and select Hide. Now for the big reveal. Press down on the button and watch as the stem pushes the blocker that opens the powder container. It works. With that final piece in place, our model is now fully functional. We have completed the assembly. If you have any questions or run into any issues, please drop them in the comments below. I'm always happy to help. Stay tuned for part 2, where we'll take this model to the next level. We'll cover visualization and rendering and explore how to present our design professionally to a client. You won't want to miss it.